tired of me. Why would they be tired of me? I've got 3 videos on my YouTube channel. No thanks to you. Dude, you were sneezing all over the floor last time. I had to get the vacuum. It's disgusting. Hello. I wasn't talking to the dog. Special right triangles. There are 2 types of special right triangles that we're going to talk about in terms of trigonometry. The 45, 45, 90, these are degrees obviously, where we have a right triangle, and it's called a 45, 45, 90 because it's referencing obviously all 3 angles within that triangle. You see here that we have exactly identical breakdown of our angle measurements. Now, in terms of triangles and geometry in general, if we have angles that open up that are the same degree measurement, the side measurements must also be exactly the same measurement, which is why we label this side X and this side X as well. So clearly, we've got a lot of symmetry going on there. Now, if we have a 45, 45, 90 degree right triangle, if both my side measurements are X, the hypotenuse would be referenced as X root 2. Now, this actually makes sense if we were to plug in a few numbers for X and solve for the hypotenuse. Let's say we had 4 and 4. Well, if I did Pythagorean theorem, 4 squared plus 4 squared, or 16 plus 16, is 32. If we were to square root 32, let's take a look and see what we have. So the square root of 32 can get broken down into the square root of 16 times the square root of 2. Well, we know what the square root of 16 is, it's 4. And because the square root of 2 is irrational, I'm not able to break that down, and I get 4 root 2. Huh. Well, we said that X was 4. So if X is 4 here, X is 4 here, that means it's 4 there as well, which is exactly what we have. Moving on. The next special right triangle we're going to talk about, or the second, or the last special right triangle we're going to talk about, is the 30, 60, 90. Same idea, basically, but the measurements on the sides are going to be a little bit different in terms of the references. So obviously, if we have a 30, 60, 90, the 30 degree measurement is going to be a smaller angle, which means that the side that it opens to is going to be the shortest of the 3 sides of the triangle. Case in point 2 for the 60 degrees, 60 degrees is more than 30, so the angle that it opens up to touch the side measurements is going to be a little bit longer. So if we have X, the 60 degree angle opens up to a side that will measure X root 3. And I don't know what that was. Hopefully it wasn't the dog. X root 3 is certainly bigger than X. Now the hypotenuse is just going to be 2 times the shortest side, or 2x. So special right triangles, well, what makes them so special? Well, the 45, 45, 90 and the 30, 60, 90 are referenced so often that they have their own specialty to them. Now, the bigger picture of this is what's in red. 45, 45, 90, 30, 60, 90 are the basis of what created the unit circle. We're not there yet, but when we get there, it's going to be fantastic. So you'll have some reference points there. But first, let's solve a couple of examples when we talk about the 30, 60, 90 right triangles. I could have done 45, 45, 90, but that's just a little bit too easy. So take a look at example 1. I want to solve for the missing values. Now, sometimes you'll see it as X and Y. In this particular case, we have an M and an N. If I have a 60 degree angle measurement here, and one side is referenced as 4, what are the other 2 side measurements? Well, let's remember back to the previous slide and the breakdown of our 30, 60, 90 right triangle. The 60 degree angle opens up to the longer side. How much longer? Well, it's root 3 longer than whatever X represents. This angle up here is going to be my 30 degree angle. It just wasn't referenced, but we can do that to help us. The opposite side from 30 is always referenced as just X. So 4 is going to be our X value. Remember that the other side, or other leg measurement, is labeled as X root 3. Well, if 4 represents my X value, then N must be 4 root 3, because all I'm doing is plugging in 4 for the 3. I'm sorry, 4 for the X. So now I have 4 root 3 for N. We knew the 4 was X here. And M, as the hypotenuse, is always going to be 2x, or 2 times our value that we got for 4. So M is going to be referenced as 8. So we've completed our 30, 60, 90. Short side of 4, second side as 4 root 3, and the hypotenuse as 8. Why don't you go ahead and try the second problem? Okay, You're back and hopefully you got the right answer. If I know the hypotenuse is 10 and that represents 2x, my short side has to be just x. So u in this case is going to be 5. And the second side, or the middle side in distance terms, is going to be x root 3 or 5 root 3. Now, I certainly could have went along the lines of using SOHCAHTOA to solve for these measurements, but that just takes way too long, where 45, 45, 90 and 30, 60, 90 are supposed to be very quick references to help us solve these problems very quickly. Moving on. Okay, some things to consider and remember when we talk about special right triangles. Number one, there are two of them, 45, 45, 90 and 30, 60, 90. As long as you remember the 30, 60, 90 in terms of x, 2x, and x root 3, you're good to go. 45, 45 is a little bit easier because you know both legs are going to be x and the hypotenuse is going to be x root 2. Number two, they're used frequently in geometry and trigonometry. We use these two special right triangles all the time. And number three, we use them so often that it is the basis for how we created the unit circle. So, spoiler alert. Wish I could say spoiler. It's not even that hard of a word. When we go to the unit circle, remember these two concepts in terms of the triangles and how they're created. It's going to make your life a lot easier. See you soon.